Hi, we're on section 12.2, more about the financial calculator, how to enter numbers, and lots of details. So if you look at this little chart, I took this from your book, snipped it and pasted it onto my PowerPoint, and this page shows you a lot of good information. So this is in section 12.2, and you guys can always just go through and read this. I'm not going to read this to you, but you can pause this and read it. You can look in your book for the same thing, because these are just some nice tips for you, and often things that students mess up. So just take a look at this, read through it, and maybe in your book even you might want to highlight some things there, or I think it's pretty small on the printout I gave you, so maybe in your book it's better. Okay, so you deposit $750 in an account paying 5% interest for 3 years, compounded quarterly, and you want to know the ending balance. So if we were to calculate this by hand using the simple interest formula, remember we did that sum in section 9.3, how many calculations would we have to do? Well, this is for 3 years and it's compounded quarterly, which is 4 times per year. And so that means we would have to calculate 3 times 4, right? 3 years times 4 would be 12 times, right? 12 different calculations if we did this by hand. And here's a chart of that where you're calculating each time your principal, your interest, and your new balance, you know, as you add the interest onto the previous principal. So principal plus interest equals your balance each time. So we would have to do a lot of calculating to get all the way to the end of that chart. Now, this is a formula that you could use instead of the calculator doing the work for you. You could use this formula. Well, as you can see, if we had to use this formula 12 times, I don't think we'd be very happy at the end of that. And so, as you see here, I said we should all appreciate the work that this amazing calculator does for us. And I find that my students usually enjoy this. They enjoy the financial calculator because it turns out to be a very interesting tool. Okay, so we're going to go back to this problem that I talked to you earlier on. You deposit $750 in an account paying 5% interest for 3 years, compounded quarterly, and what is the ending balance? All right, so the number of periods for this are going to be 3 times 4, which would be 12. And the periodic rate is 5 divided by 4. So that ends up being 1.25%. That's our periodic rate. If only I could write. And then present value is this $750 with a negative because it is money going into the bank, so we don't have our hands on it anymore. Are we making a quarterly payment? No, it doesn't say anything about that. And what are we computing? We will be computing future value. All right, so we're going to put that all in the chart. 3 times 4 equals, and as you put this in, you can put it on your calculator as well. And then that's negative 750. There is no payment. That's where we're going to put our 0. And then future value is what we will compute. So compute future value. And now you're going to compute this with your calculator. Remember how I told you it's a good idea to circle this, because then when you look back at your work, you know what you were computing. So when you press compute future value, remember on your calculator, press the compute key and then press the future value key, you get 870.57. And so that's what would happen for this account in 3 years. We would go from $750 to $870. and that accounts for all that interest that you earn. So if you want to double check yourself, because sometimes you're not getting the right answer, so instead of clearing everything out, you can actually use your recall key. Remember, that's the RCL key, and we can check and see, do I have the right numbers in the categories in my calculator? So let's look at this. On this last question, if you press recall N, you should see this. Right? There were 12 periods, 3 years, 4 times per year. When you press the IY key, you will get 1.25. That's our interest rate for our periodic interest rate. For present value, you should see, I don't think it has the dollar sign, it just has negative 750, and it'll have the 2 zeros there. And then on the payment, it will look like this. All right, so let's look at this next slide. And so you can actually just push your recall key and review everything that you have entered, and then you will see each thing on your screen. If you don't press recall first, then you will enter whatever you had on your screen. So you may end up with, you could mess up your numbers if you forget the recall first. Sometimes the numbers just aren't coming out right, so that's where you want to reset your calculator. Remember, that would be the second key, and then you hit the plus minus key and push enter, and that clears your calculator. All right, and then every time you begin a new problem, you can clear the TVM keys. You can see I have those circled, and that's just the second key and then future value. And that just clears out just the TVM keys so you can enter new data. All right, let's look at this question. Okay. So Sebastian is a soda pop addict and wonders how much money he could accumulate if he stops drinking pop and deposits that $120 per month he spends on the stuff in his savings plan. Sebastian just turned 25. If his savings plan earns 5.8% compounded monthly, what amount would he have at retirement 40 years from now? So that would be when he's 65 years old. So we're going to go through and look at these numbers that we just talked about, right? 120 per month. That's important that we think about the fact that it's per month. And then he's 25, but that doesn't really matter because we're using the 40 years. This is our interest rate. And so he's going to take this monthly amount and put it into an account and see what he ends up with at the end of that. So we are computing future value, right? So we're going to be circling our future value. Now, 40 years compounded monthly. Oh, I didn't put any highlighting on that part, right? Compounded monthly. And so monthly means 12 times per year. So 40 years compounded monthly 12 times per year. So make sure you push your equal sign, and that number is what will go on in. And in this case, it's going to be 480. We're going to take 5.8, divide that by 12, push your equals key, 0 here, and our payment is 120. And that's with the decimal places. If you put those on, that's kind of like the proper way. Now, we're going to compute future value, and you'll find that that $120 per month grew very nicely to $226,401.88. And so that was a pretty nice growth. Now you can figure out how much was put into the account by taking 480 times 120, and so he actually only deposited less than $60,000 in the account, and this is what it grew to. But this is a lot of time. 40 years is a lot of time. So that 40 years of letting some money grow is a really good thing. And time is on your side whenever it comes to compound interest. All right, so I hope that you can see the use of this calculator and that you're starting to figure some things out. Don't worry, we're going to do lots of practice coming up, and so this is just the start of using the financial calculator. All right, I'll stop the video now, and there will be a new one for section 12.3.